This video is going to show how Adapt Builder handles the need for reinforcement to meet spacing requirements in a reinforced concrete slab. And we're going to also show how this is applied in conjunction with user-entered reinforcement or base reinforcement. So I'm going to go ahead and open Builder here. We're going to open this in RC only mode. So this is a non-post-tensioned or non-pre-stressed slab. We're using Floor Pro mainly for this model. And what I'll do first is go ahead and just set up a model here. I'll use the Floor Wizard to set up this model. And we're going to do a 3x3 bay, 28-foot span structure. We'll use a 10-inch slab here. And we have some loading, just some basic loading. So this is our slab. And what we're going to do is we're going to analyze the slab. I'm going to go ahead and mesh the slab. And then you'll notice also that for the load combinations, we're going to run this for just a couple of service and a couple of strength combinations. So service would really be required to generate, to evaluate things like deflections and maybe stresses, but also to generate minimum reinforcement. So for this two-way slab, the minimum reinforcement would be temperature shrinkage steel, and then strength would be used to determine how much steel we need for capacity against these factored demand moments and loads, or demand forces rather. So I'll go ahead and analyze the slab for this bare model, and I call it bare because I don't have any base reinforcement in the slab. We're going to have the program generate all the reinforcement. So we've analyzed the structure, and now I'm going to generate my design sections and design the sections. Okay, once that's done, I'll go back and go to my default display, and I'm going to calculate the rebar plan for the envelope. This includes the needed rebar for both service minimum and strength reinforcement. And you can see there's quite a bit of rebar. We're going to focus in on just one of the strips. So I'll look at an X direction strip. Because it's symmetrical, I'll take a interior strip in the X direction. And so under rebar, I'm going to isolate under display manager the rebar in only the X direction here. Okay, and if I go back to my strips, I'll turn on the X strips. And we're going to look at this strip that you see. First interior from the top, this one here, this strip. Okay, and we have 24 number 8 bars from here to here. Now one thing I can look at is that bar spacing is 14 inches. If I look at the design cuts for this particular section, so I'll turn these sections on, and I'll just go to midspan, one of the cuts near midspan, we can see that the required reinforcement for the bottom is 6 square inches. 6 square inches, and minimum reinforcement controls that. If we do a calculation and we take 336 times 10 and we multiply that by the required temperature shrinkage, 0.0018, we get 6 square inches of steel. And that results in so many bars. Now the bar size we're using is a number 8 bar. That is set under rebar, rebar size and material. So for two-way slab, the bottom bars here by default is set to a number 8. Likely we would use maybe something a little less than that for a two-way slab of this thickness, but that's the bar size currently being used. The area of that bar is 0.79. So if I take 6 square inches divided by 0.79, by calculation, I actually only need 7.6 bars. Round that up to 8. Okay. So if we look and see where's this miss, or this the misalignment, let's say, between the bars shown here and the calculated required number of bars, which is 8. We have 24 shown, but we just showed that we need only 8 bars. So if we assume that one of the 8 bars is aligned here, I'm just going to draw this. There's another bar here. So those are 2 bars. And really we need to fill this in with an additional 6 bars. Something like that. Okay, so if we take the 336 divided by 7, that actually results in a spacing. If we had number 8 bars, the spacing would be at 48 inches on center. So at this section, the required reinforcement is controlled by minimum requirements, which is 6 square inches. That technically is 8 bars. However, there's another thing that's happening. The program is actually checking the amount of bars per spacing in this section of 336 inches. So if you go to Rebar Roundup, you can see there's this option here for bar spacing, and it's not disregarded. This means that the program is saying, okay, whatever you need for strength or service, which in this case is 8, if that resulting spacing, in this case is 48 inches, does not meet 18 inches or 1.5 times the slab thickness, the program is going to add bars to meet this requirement. And that's what's happening. It's actually adding 16 more bars so that they are spaced no more than whatever the minimum is of this setting. If I disregard this and I go back and go ahead and calculate the rebar again for the envelope, you can see now we need 8 number 8s, and that's because I turned the spacing check off. Now, I'm going to add number 8 bars at 8 inches on center, or maybe even 6 inches on center, as a bottom mat in this slab. So I'll select the slab. We're going to go to rebar. I'm going to add a mesh here. So we're going to do a bottom mat. We're going to do bar size, and we'll do 8s, and we're going to space those at 8 inches on center. There's my bottom mat. If I go to a side view, you can see the bottom mat there also. You could also see that just as a secondary way to look at that through this rendering tool. There's my bottom mat of steel. And we're going to now redesign the sections. I don't need to reanalyze, I just have to redesign here in this case. So I'll go back and redesign my design sections. And I'm also going to go back to Rebar Roundup, and I'm going to turn off disregard. Okay, and I'll redesign again. And what I'm trying to show is that even if the user inputs a mesh or base reinforcement that technically is spaced to take care of the spacing requirement, the program does not consider any user-defined rebar when checking spacing. So if I generate the rebar again for this section here, you can see that there's no rebar required. And what that means is that this amount of base reinforcement was enough to meet the service and strength requirements. We needed 6 square inches previous. This is enough to handle the 6 square inches. So because there's no rebar required for service or strength, the program doesn't check the spacing, even though it's set to not disregarded. If I loosen up this spacing a bit, maybe I go to 12 square inches, and I redesign the cuts, I'll go ahead and design the sections again. Okay, and let me generate the reinforcement. Again, there's no rebar needed. In fact, if we double click on this section cut here, you can see the amount of base rebar in that section is 22.1 square inches. I only needed 6 per the calculation we looked at earlier, so I'm going to drop this way down so it's just under 6 square inches. And I'll actually space this at, let's do 40, actually 50. We said 48 earlier when we calculated that for the spacing. We'll do 50. And again, we're going to design the cuts. And I will calculate the rebar again. Okay, now we need 24 again. So it goes right back to that 24. If I go back to the design cut, you can see we only need 0.7. We have 5.3 square inches per the base reinforcement. If we calculate the requirement, we still only need 6, so that's where the 0.7 comes from. But because we only added enough base and we still need a little bit of calculated rebar here, the program sets that trigger for checking spacing, and we get back to this 24 bars. So I'm just showing that the program does not consider the mesh rebar when it comes to the spacing check. What that means is if a user inputs mesh reinforcement or base reinforcement of any kind, it could also be banded or distributed reinforcement, you should make sure you go into rebar lengths and turn this option off under rebar roundup spacing. Turn disregard, select disregard, meaning turn this option off. If I come back and then regenerate the plan, we're only going to need one number 8 bar there shown here. So that's how the minimum reinforcement and the spacing reinforcement and even strength reinforcement are all working in an RC slab when you have the spacing option turned off or on. If you have any questions, please contact support@adaptsoft.com.